Hello friends, welcome to another tutorial in microprocessor. In today's tutorial we'll talk about subroutines in 8085 in context with call and return instruction. Now if we look at the basic structure of a program in microprocessor, it consists of essentially two parts, and the terminology and keywords involved in understanding the basic structure of a program has two parts: routine and subroutine. The main program that the microprocessor executes is known as a routine, and a subprogram is a subroutine. So let's understand this more elaborately. For example, a program is written in the memory of a microprocessor at location 2000. So progressively, as the program is written, the memory locations are also increasing. So within this large program, at two different points in memory, at 20A0 and 2100, we get the need to add two numbers. Now there are two approaches of solving this repetitive need. One approach could be to write code to add two numbers at this location and at this location and at some other location where the need may arise. That would make the main program or the structure of the program more lengthy and would make it non-modular. And another approach could be to identify those areas which are repetitive. So as in this case, the repetition involves adding of two numbers. So we'll write a subprogram, which will be also known as a subroutine, at some different location, pretty far away from the main program. So what I do is add A000, which is far off from 2000 where the main program is written. I write a small little program to add two numbers, and whenever I get the need to add two numbers, I can simply jump to this location, execute these instructions to add two numbers, and come back. How can this be achieved? We know that our main program can go to a subroutine and then come back, and that way our program can become more modular and it makes more sense. This process would essentially involve some mechanism to be fulfilled, which are: number one, to go to that location and then come back to the location where we left off. So as I mentioned here, we would need jumps or branching or diverting into a subtask. So that is what the need of the programmer is, and that is solved by using call and return instruction. Now let's talk a little bit about call and return instruction. So whenever we need to take ourselves to this sub program, we simply need to know the location of that program, and we can write this very simple command, which is call and followed by the memory address where the subprogram is located. And what it'll do is it'll take the microprocessor to this location and it'll start executing the instructions written in that location and progressively in the following locations until it encounters a return instruction, because every subroutine must terminate itself with a return instruction. And when return instruction is seen or encountered, it will come back to the immediate next memory location where we left off. So in other words, if call is a 3-byte instruction and it is written at 20A0, so essentially we would want to come back to 20A3, because 20A0, 20A1 and 20A2 are the memory locations where call instruction was written. So we do not want to come back to these locations. We wish to come back to the next location where we left off. This return instruction will take us back to 20A3 and call will take us to A000. So that's the essence of how call and return instructions will work in tandem. And in order to achieve that, we'll need to see the internal working. And let's talk a bit about call and return instruction. It's a 3-byte instruction. It is unconditional and it manipulates SP. Now, this is the most important point, that it manipulates the stack pointer, transfers the value of PC, and of course, as we discussed in the previous slide, if call was written at 20A0, we know that 20A0, 20A1, 20A2 will be memory locations occupied by the call instruction itself. So 20A3 is the memory location that we need to save somewhere so that return can use that memory location to come back to where we left off. So value of this PC, this program counter where we wish to come back, is transferred to stack. This should be stack memory, and stack pointer is decremented by 2 and stack pointer is decremented by 2. So currently my stack pointer would have been pointing at some locations, so 20 and A3 will get stored and stack pointer itself will get decremented by 2, because stack pointer always needs to be ready for any push or pop instructions, because you need to understand the working of stack pointer for all the push and pop instructions, because stack pointer is that area where the pointers to the memories are stored. So this is the most important point, and if you understand this point well enough, return is not difficult to understand, because it is exactly opposite to that. It's a 1-byte instruction, though it's unconditional and it manipulates stack pointers in exactly the opposite way. The value of program counter which was stored in the stack, in our case it was 20A3, it is retrieved from the stack memory and it is incremented by 2, because now we have popped something from the stack, so we have the obligation to increase it by 2. Here call was pushing something on the stack, so it had the obligation of decrementing it by 2. And we can understand this more by taking up a suitable example that I'll do in a moment. But as I mentioned here, call is unconditional, return is unconditional, but we have a set of conditional call and returns also. So if you encounter an instruction which says call if carry, call if not carry, call if 0, call if not 0, call if parity is even, call if parity is odd. So all these instructions are conditional calls, and of course they are also 3-byte instructions, because they are followed by 16-bit address where the program will jump. And on the other hand, you have an equivalent set of return instructions also for conditional returns. Now, here I've taken up an example that whenever call instruction is executed, let us say my stack pointer was pointing to 5000. So 5000 was the top of my stack. So we need to go to A000, which is specified in the instruction itself, but the main task is to store A0, A20, A3H, where we wish to come back. So this location needs to be stored somewhere in a safe place so that we can come back to this location also. So it gets saved to the stack. 220 and 43 get stacked on 5004 FFH, and the stack pointer is now decremented by 2, and the new value of stack pointer becomes 4FFE. So anything, if we get another push instruction or call instruction, it will get the new program counter value will get stored in these two locations, and stack pointer will get decremented by 2 again. And on the other hand, when return is encountered, it'll retrieve the address from these two memory locations of the stack, and it'll increment the stack in the opposite direction. So stack pointer will be incremented by 2. That is how it works. So if we sum up our discussion, call is more or less like a jump instruction. It's kind of a misnomer if we think of call as, you know, calling some smaller little program from a distant location to the main program. But the fact is, our main program is jumping to that location. We are going to that location. That location isn't coming to the main program's location. That can never happen actually, because whenever we wish to perform that operation, we'll need to go to that location where the small little program is written, and we can execute those few code lines and then come back. So I hope this quick tutorial on subroutines and call and return instruction was of help. If you liked the video, give it a thumbs up. I'll see you in the next video. Take care, have a great day ahead, and a good life. Bye.